Modern AI models excel at pattern recognition, classifying images, generating text, and finding relationships in data. So you upload a photo and your phone instantly tags it a cat, or a beach, or a birthday, which is pretty impressive, right? But here's the catch. If you ask why it knows it's a cat, it can't explain it. It just recognizes what it's seen before. It's like a student who memorizes every answer, but doesn't actually understand the material. That's where most of today's AI still is. They don't reason, they just see correlations in data. If a cat is upside down, drawn as a cartoon, or described in a tricky sentence, they might miss it. So the real question is, how do we move from pattern recognition to understanding? How do we get AI that doesn't just see, but also thinks? Think of it like a botanist with a checklist. If something has green leaves and a stem, it follows the rule. Leaves and stem, it's a plant. It's logical and structured, and it reasons step by step. But if you show it a cactus, it gets confused. It freezes. Wait, no leaves? Maybe not a plant? That's the weakness of rule-based logic. It struggles when reality doesn't fit the template. And then came neural networks, which don't rely on explicit rule. They learn from examples or data. You show them 1,000 pictures of plants and they'll recognize the pattern. So when they see anything green, they confidently say, that's a plant. But here's the catch. Show them a plastic plant and they'll probably still say the same thing. Because they've learned what plant looks like, not what they are. They recognize the pattern, but they don't reason about meaning. So we've had logic without intuition and intuition without logic. Wouldn't it be great if we could combine them? That's exactly what's happening in a field called Neurosymbolic AI. In simple terms, neuro comes from neural networks, which is the learning part, and symbolic comes from logic, which is the reasoning part. Together, they create systems that can both recognize and reason. For example, a neurosymbolic agent looking at image of a street sign might detect shapes and colors, which is the neural side, and then apply rules, like if it's red and octagonal, it's a stop sign. So even if someone adds a sticker, changes the lighting, or paints it with a word, it still knows what it's seeing, because it understands why a stop sign looks the way it does. That's the difference between recognizing and understanding. Here's where it gets exciting. These systems don't just apply fixed rules, they can actually learn new ones. Imagine we teach a model that mammals have fur, and then it learns about whales, no fur. A typical model gets confused. But neurosymbolic systems can reason. Whales give birth to live young and have lungs, so they're still mammals. It updates its logic without retaining on millions of examples. That's called metalearning. Learning how to reason. Under the hood, Neurosymbolic AI uses logical frameworks like first-order logic to build reasoning layers on top of neural network outputs. Developers can integrate these symbolic reasoning engines with pre-trained models or reinforcement learning pipelines to make systems more explainable and robust. So what does this mean for developers and technologists? In science, developers can use neurosymbolic AI to analyze chemical structures, reason through molecular properties, and simulate potential drug candidates. In finance, they can analyze transaction patterns to detect anomalies. In law, they can extract and reason through clauses in legal documents. And in machine learning workflows, neurosymbolic AI can help debug models, check output consistency, and validate reasoning steps, bridging the gap between what the model predicts and why it predicts it. This isn't about replacing people. It's about creating systems that work with us, making reasoning and interpretability more accessible to every developer. As we build systems that reason, we also need to think about responsibility. When AI can also explain its logic, it's easier to audit. And that's essential for governance, ethics, and trust. But there's still a human element. creativity, judgment, and empathy, and that no system can replace. So the real opportunity isn't AI versus human. It's about creating AI systems that augment human decision-making by combining symbolic reasoning and neural network-based learning. As AI gets smarter, our role is to stay curious and understand how these systems think. Neurosymbolic AI is bringing reason back into intelligence, helping machines and humans solve problems together. That's the future of AI. Logic and learning working hand in hand. Stay curious.